All right, so this week we are going to talk about using SPSS to perform multiple comparisons and contrasts, but in the opposite order. So we're going to do contrast first, and then we're going to do multiple comparisons. So as a refresher, a contrast is a technique that we utilize to compare a set of 3 or more means by utilizing or looking at specific combinations of the means. So I have a few different examples of contrast that I'm going to show you. And then the multiple comparison is a follow-up technique that we utilize after an ANOVA to determine where the differences lie among a set of means. So the data set that we're going to use for today's lab is the same data set that we used last week, which is the program.sav data. So the program.sav data gives us 4 different groups of scores on a standardized test. 4 different groups of scores on a standardized test where each group corresponds to a different teaching method. Okay, so that data set, we just need to I need to upload here. On my data. Okay, so program.sav. Okay, and then I will click open here, program.sav. Okay, so here's our data. So we have the 4 columns corresponding to the teaching method of interest. Okay, so let's review reorganization of the data from last class. I had a message asked during the week about restructuring the data on assignment 2 when comparing the velocities of the 2 experiments that were conducted in it was for question 1, and I don't remember the years of the experiments. I think it was like 1982, no, much earlier than that, 1882 and something a little bit later on. So this restructuring approach that we can take for our data sets, we can utilize this even in a situation where we only have 2 variables. So this isn't an exclusive technique for ANOVA experiments. This is just a way of basically incorporating an index value with our groups. And the reason we want to do that is because most of the SPSS tools require that the measurements are all in one column and that the second column gives all the indexes. So this is more of a practical tool to allow us to understand how to restructure data in general. All right, so we're going to restructure these 4 methods so that all the scores are in one column, and then we have an index that corresponds to the method number in the column next to it. And we can do this on assignment 2 for question 1 as well, but we would just be doing it for 2 columns. So we go data, restructure. Okay, so we're data restructure. Okay, we want to restructure variables into cases. Click next. We click next here. So how many variables do you want to restructure? Just 1. We take our 4 variables and we stick them into the target variable slot. We can change the name if we want to. So we can call these scores, for example. And then here we can call this method if we wanted to, for example. So this is going to be the label attached to each variable. And then this is going to basically just being, this is just saying we're going to have a scores column with the scores from all 4 methods. Click next. How many index variables do you want to create? We only need 1, so we click next. What kind of index values? 1, 2, 3, 4 is fine. We could also do variable names, but we'll just use sequential numbers. Click next. Handling of variables not selected. Keep and treat as fixed or drop variables from new data file. This doesn't apply to us because we're using all the variables. In the on assignment 2 for Q1, you'll probably want to keep and treat as fixed variables the other 2 columns because we have all 4 in the same data set. But you could also just create a new data file and then just re-upload that after as well. If anything is missing, you'll want to discard. So I would select discard for assignment 2. We can select it here as well. It's not going to do anything. So we can select discard, click next, restructure the data now, click finish. Okay. All right, so, oh, this popped out 2. Okay, so, oh, gotta make sure I didn't mangle this too badly, I guess. So I think actually this method variable here, we don't want this. So maybe don't change that name to method. I think that that might have messed it up because the index looks like it's structured it properly. So I'm gonna just delete this. Okay, there we go. Okay, now I'm just gonna do a quick check to make sure that my ANOVA result matches what I got last class. So to run the ANOVA, we're gonna go analyze, compare means, one-way ANOVA. Our index is gonna be score goes here, index goes here, click OK, 7.126. Okay, so that looks good. All right, so here's our restructured data. So you can see that all we have done is we've taken the 4 columns, we've put them into one column, and then we've attached an index variable to that. Right, so we can sort this if we want to. You don't have to. It doesn't really make a difference, but if you want to read it as like groups, you can do it this way. Okay, so once we conduct an ANOVA, what we have done is we have basically asked the question, is there evidence of a difference among the treatment means in the data set? So our ANOVA result from the last lecture is shown here. So this is from the lab material for lab 3. We have a p-value of 0.001, which means that we can reject a null. So we have evidence that a difference exists among the 4 treatment means or the 4 method means or the 4 mean score values for each population. However you want to think about this is fine. So following from rejection of the null hypothesis in an ANOVA, we would then be interested in making comparisons among the means. And we can do these comparisons in 2 ways. We can perform what is called a contrast, or we can perform what is called a multiple comparison. Now, the contrasts we will demonstrate across examples 1, 2, and 3. The multiple comparison will be its own question because there's only one way of conducting the multiple comparisons. Okay, so the first question says, given the fact that we rejected the null hypothesis of the ANOVA for this data, is there evidence that the mean score from the first approach is different from the mean score of the second, third, and fourth approaches? All right, so what we are doing here is we are setting up a hypothesis test about the contrast that compares mu1 to the average of mu2, 3, and 4. Sorry. Okay, so the contrast is going to look like this. So our contrast symbol is going to be gamma. So we're going to have insert, advanced symbol, okay, and then where are the Greek letters again? Sorry, I know that this is a little bit annoying, but I'll find it in a second. Okay. All right. So the letter we use to designate the contrast is gamma. So the contrast of interest here is going to compare mu1 to the average of mu2, mu3, and mu4. So we're going to have gamma is equal to mu1 minus 1 over 3 multiplied by mu2 plus mu3 plus mu4. Okay. So this is the contrast that we are interested in talking about. We want to compare the average of the first approach to the average of the second, third, and fourth approaches. So that is mu1 minus 1 over 3 mu2 plus mu3 plus mu4. So that's the average of those three means. The question specifically states, is there evidence that the mean score from the first approach is different from the mean score of 2, 3, and 4? So our null hypothesis for this test is going to be gamma equals 0 versus gamma not equal to 0. All right. Now, the significance level for the contrast will be the same significance level that we utilized for the ANOVA. So for the ANOVA experiment, we utilized alpha 0.05. So for the contrast, we will utilize alpha 0.05. Okay, now what we have to do is compute the test statistic for the contrast. So we go to SPSS and we go analyze, compare means, one-way ANOVA, right? And now what we do is we click contrasts, which is within the one-way ANOVA command, right? Then we check polynomial and we leave degree as linear, okay? And now what we do is we add our coefficients for each of the values in the contrast and we go in order. So our coefficients, as a reminder here, so the general contrast has form gamma equals C C1 mu1 plus C2 mu2, C3 mu3, C3 mu4. So the general contrast for 4 population means, I should say, has form shown here. Okay, so for the problem that we are working on, we're going to have the following. We have C1 equals 1, C2 equals negative 1 over 3, C3 equals negative 1 over 3, and C4 equals negative 1 over 3. Right? So those are the 4 coefficients that we are going to be working with in this problem. So in SPSS, we enter them in the order that they appear. So we enter C1, then we enter C2, then we enter C3, and then we enter C4. So inside our contrast box, we would go 1, add. And then we would go negative 0.33. So we can't Okay, negative 0.33 because it gives us the extra spot. So one of the limitations of SPS in this case is you can see that it has a restriction on the number of decimal places that you can use. So you can only get 2 places or 4 characters in total. So we have to enter 1/3 as negative, or negative 1/3 as negative 0.33. So that'll be our second coefficient. C3 was the same thing. So we add this again. And then C4 was the same thing. So we add that again. All right. And then we click continue. And then we click OK. Okay. And then here you can see SPSS. First off, it gives us the ANOVA table in a slightly different form above. Then it gives us the contrast coefficients. So here's contrast 1. So C1 is 1, C2 negative 0.33, C3 negative 0.33, C4 negative 0.33. This table here gives us the output for the value. Okay, so we're going to take this table and we're going to insert this into our solution. Okay, now our test statistic is given in the table. So you can see here that we have scores. Assume equal variance, does not assume equal variance. Because we are following up from an ANOVA, we are going to use the equal variance score in the contrast. So our test statistic will be negative 3.112. We are performing a two-tailed test. So our p-value will be the p-value given in the table, which is 0.003. Then we can say, since the p-value is less than alpha, we can reject H naught. And then we would write, at the 5% significance level, the data provides sufficient evidence to suggest that there is a difference between the average score for the first method and the average score of the second, third, and fourth methods. So like before, we're pretty much just running a hypothesis test about the contrast. The only real tricky part here is just setting it up in SPSS, and that is just finding the coefficients that are corresponding to the contrast that we are working with. Does anyone have any questions so far? Okay, let's look at another example. Question 2. Is there evidence that the mean score of approaches 1 and 2 are different from that of approaches 3 and 4? All right, so this is pretty much the same problem we just worked on, except that we are now comparing the average score of mu1 and mu2 to the average score of mu3 and mu4. So our contrast here is going to look like what follows. So we'll have 1/2 times mu1 plus mu2. Sorry, and then I should have a multiplication symbol up here as well. Okay, and then this is going to be minus 1/2 times mu3 plus mu4. Okay, so therefore, we're going to have C1 is 1/2, C2 is 1/2, C3 is negative 1/2, and C4 is negative 1/2. Now we're still asking if there's evidence of a difference. So our null hypothesis is going to have the same form that it had in question 1, except that our contrast is different. So we're going to have a different result. Our significance level will still be 0.05 because that follows from the ANOVA experiment. And now we just need to set up our contrast again to get the values or to get the test statistic for the hypothesis test. So in SPSS, once more, we go analyze. compare means, one-way ANOVA, contrasts. Okay, so now we'll remove each of these components. And now we'll start by entering in the values of the contrast. So we'll have 0.5, 0.5, negative 0.5, negative 0.5. All right, and then, so this is C1, C2, C3, C4. Click continue, click OK. All right, so you can see here, the output has the same form that it did before. So in this table, we have the contrast values. So C1 is 0.5, C2 is 0.5, C3 is negative 0.5, C4 is negative 0.5. And then in the second table, we have our test statistic and our new p-value for the contrast of interest. Okay, so we would take this value, right, where this table is. We're going to change the photo here to the new table. Okay, our p-value here is now 0.057. So now we can say, since p-value is greater than alpha, we do not reject H naught. And then we would write, at the 5% significance level, the data do not provide sufficient evidence to suggest that there is a difference between the average score of the first and second method, between the average scores of the first and second method and the average score and the average score of the third and fourth methods. Okay, so that's our second illustration of a contrast using SPSS. And probably the trickiest parts here are just setting up the contrast itself. So just finding the coefficients for each term. And then just inputting that into SPSS. All right, so in question 3, we'll do another example of a contrast. So here we have, is there evidence that the mean scores of approaches 1 and 2 are less than that of approaches 3 and 4? Okay, so in this question, we have the same setup that we had in contrast number 2. So we're still comparing 3 and 4, or the average of mean 1 and 2 to the average of mean 3 and 4. The only difference here is that we now have, are they less than that of 3 and 4? So in our alternative hypothesis, we'll have gamma less than 0. So then in the null hypothesis, we'll have gamma greater than or equal to 0. Okay. Now, when we set up the contrast, you will notice that the setup for this comparison in question 3 is exactly the same as what we did in question number 2. So if we go to SPSS, we click Analyze, Compare Means, One-Way ANOVA, the values that we are considering are exactly the same in question 3 as they were in question 2. So the output here is going to be exactly the same. The only difference is we have the less than sign in the alternative. So what is the only value that's going to be different, or what does that affect in the hypothesis test? So step 1 is different, step 2 is the same, step 3 is the same. What do we do to the step 4 value to accommodate for the fact that we now have a directional test? Yeah, very good. Okay, so we'll have 0.057 over 2, which is 0.02535, I think. I don't know if that's correct. I'll have to check. Okay. Doesn't work like that. Okay, I'll just give this a quick.
It's 0.02850.
2850. Thank you. I don't know what I was doing. Friday afternoons, eh? Thank you. Okay, so now we can say that the p-value is less than alpha, so we reject H0, and then we can say at the 5% significance level, the data provides sufficient evidence to suggest that the average score of the first and second methods is less than the average score of the third and fourth methods. Okay, good stuff. So here, I just want to give a little bit of insight into the direction of the test. So we have the contrast gamma So we have the contrast gamma is equal to 1/2 times mu1 plus mu2 minus 1/2 times mu3 plus mu4. So if we were to set this less than 0, we would have 1/2 mu1 plus mu2 minus 1/2 mu2 mu3 plus mu4 is less than 0. Okay. If we rearrange that, you can see that simply by moving this part to the other side of the equality, we end up with what we are interested in testing. Okay, so the direction of the alternative corresponds to how the contrast is set up, and then that corresponds to, the direction of the alternative corresponds to how we actually set up the test. So if we take gamma, which is 1/2 mu1 plus mu2 minus 1/2 mu3 plus mu4, we have gamma less than 0. So we have that expression less than 0. When we move the average of mu3 and mu4 to the other side of 0, you can see that we now have the average of mu3 plus mu4 being greater than the average of mu1 plus mu2, hence the alternative being a less than test. And then again, we're going to have the exact same output here because the setup of the test is exactly the same as it was before. The only difference is we have to divide our significance level by 2 because these are always two-tailed p-values, and that gives us a p-value of 0.0285. So then we can say, since p-value less than alpha, we reject, and therefore we have evidence that mu1 and mu2 is actually less than the average score of mu3 and mu4. So SPSS output always gives us two-tailed p-values. So in the first part here, we have a two-sided test, gamma not equal to 0. So this is the p-value corresponding to that two-sided test. So we do not have to adjust it. In the second part, or in part 3, we have a lower tail test. So this is a one-sided test. We still have the same two-tailed p-value. So in order to turn that into a one-sided p-value, we have to divide it by 2. Does that make sense? So it's interesting actually when you think about this problem, because you can see that in question 3 here, we're rejecting the null and saying that this value is actually less than the other one. So the quantity mu1 minus the average of mu1 and mu2 is less than the average of mu3 and mu4. However, if we perform a two-tailed test, we don't have any evidence of a difference. So there's evidence that at the same significance level, we're less than the one quantity is less than the other, but at that same significance level, there's no evidence that they're different. It's an interesting result. So it sort of shows that the two-tailed test is the more conservative test. So if you reject in a two-tailed test, that's certainly going to give you evidence and direction, but sometimes you can reject in a directional test, but not reject in the two-tailed test. So it's an interesting result just to think about. Okay, so those are the 3 examples of contrast that I wanted to go over. So I just wanted to show you how to set the contrast up in SPSS, how to run through the steps of the test, which are very similar to what we have seen before. And then I wanted to show, the p-value adjustment, which is again something we've seen for our two-tailed tests and our one-tailed tests in SPSS as well. The last topic that we need to go over is constructing the multiple comparisons for all of the combination means. So in exercise number 4, I have perform a multiple comparison to determine which approaches have led to a difference in mean test scores. Okay, so effectively what we're doing here, so as a reminder, a multiple comparison takes all possible pairwise comparisons and performs statistical inference about those values, about those comparisons. Okay, so in this illustration, we have 4 population means or 4 treatment means. Therefore, there are 4 choose 2 equals 6 pairwise comparisons of interest. Okay, so to perform the pairwise comparisons in SPSS, again, we start with the ANOVA command. Oh, sorry. Okay, one sec. Okay, so we start with the ANOVA command. So we go analyze, compare means, one-way ANOVA. Okay, and now from this, we click post hoc. So the setting up of the multiple comparisons is done through the post hoc tab. So contrast was done through contrast, multiple comparisons is done through post hoc. And actually, let's just clear this part out because otherwise we're going to get the contrast output as well. Okay, so you can see within the post hoc command, we have a variety of different multiple comparison procedures that we can consider. So we have least significant difference, Bonferroni, Tukey, Tukey's B, Scheife, SIDAC, SNK, all different types. In the lecture set, the approach that we focused on was the Bonferroni approach. So we can consider multiple different comparisons at once, or we can just consider one of them. Let's use the Bonferroni approach to be consistent with what was given in lecture. But again, it's easy to select a different multiple comparison tool depending on what the question is and what you're interested in. So we could do LSD just by clicking the box, or we could do Tukey just by clicking the box, or we can do a set of them by having all 3 clicked. For now, we'll just do one set so we can talk about interpretation. In the significance level box, we're going to set the significance level for the overall experiment. So this will be the same significance level that was given at the 0.05 level. So we click continue and we click OK. All right, so here's our output for the multiple comparisons of interest. So let's take this output, pull it into our Word document so that we can discuss it. So we're going to have at okay, so we will have the following output from SPSS. All right, now let's try and make sense of this value. So let me see if I can get this table. Okay, there we go. Okay, so what's happening here? Well, the SPSS output is showing us the comparisons of interest. So for example, this is saying compare mean 1 to mean 2, mean 1 to mean 3, mean 1 to mean 4. Then it's saying compare mean 2 to mean 1, mean 2 to mean 3, mean 2 to mean 4. So you can see already that one of the things that we run into with the SPSS output is overlap. So for example, if you consider the output for mean 1 versus mean 2, that gives a difference of negative 1.36. But then if we consider the output for mean 2 versus mean 1, you see positive 1.364. So that's the same quantity, we just have a different sign because the direction of the means has changed. So we're actually only interested in the 6 values that are of interest to us. So as stated above, there are 6 unique multiple comparisons. They are 1, sorry, one second. So they would be H subscript 0, mu1 minus mu2 equals 0 versus H subscript A mu1 minus mu2 not equal to 0. Okay, so that's 1. Okay. The second comparison would be mu1 versus mu3 against the alternative mu1 versus mu3 is not 0. The third one would be mu1 versus mu4. The fifth one would be mu2 versus mu3, mu2 versus mu4, mu3 versus mu4. Okay, so these are our 6 comparisons of interest. Okay, now in the SPSS output, you can see that we have a confidence interval and we have a significance level where and we have a sig value, which is the p value for the test. Right? It's weird, like some of these are so close to 1. Okay, so we can use the p-value or the confidence interval to determine if there's evidence of a difference, because that's, in the end, the goal of the multiple comparison is to determine if there's evidence of a difference. So here, for example, we would have p-value equals 0.079, and then we would have CI is negative 2.82 to 0.09. Okay, so we can determine the result from either, right? So this is implying here in the traditional way, since p-value less than alpha, do not reject H0. Okay. Similarly here, since the CI contains 0, there is no evidence of a difference, right? So we simply have agreement between the hypothesis test based off the p-value and the confidence interval. So the CI and the p-value are both giving us the same result. I'm just showing this to illustrate the point that we have agreement, but you can do it either way. You can just take the p-values directly and say no evidence of a difference. Or you can just take the CI and check to see if it contains 0. And if it does, there's no evidence of a difference. Okay, so then for the second comparison, we're now going to have p-value 0.001. Okay, so now we're going to have, oh, sorry, this is greater than. Since p-value less than alpha, reject H not, therefore there is evidence of a difference. And then the CI here is negative 3.73 to negative 0.81. Okay, so since the CI does not contain 0, therefore there is evidence of a difference, right? And we're just continuing with this pattern for all of the comparisons that are of interest to us. Okay, so the third comparison states, let me just move this up. I'll just see if I can get it all. So the third comparison is mu1 versus mu4. So the p-value here is effectively 1. Okay, so in that case, we would say since p-value greater than alpha, do not reject H0, therefore there is no evidence of a difference. The CI here is negative 2 to 0.91. Okay, so since the CI contains 0, there is no evidence of a difference. Okay, the fourth comparison is mu2 versus mu3. So we would go into the second column, mu2, mu3. All right, so this is going to be another do not reject here. Okay, so we have a p-value 0.548. Okay, and we have a confidence interval negative 2.37 to 0.55. Okay, then we would do mu2 versus mu4. This will be another do not reject. So in this case, we have a p-value 0.764. And our confidence interval is negative 0.64 to 2.28. All right, and then the final comparison is mu3 versus mu4. This is a rejection. Okay, so I'll just grab this one. Okay, so mu3 versus mu4, we have 0.013. And our confidence interval is 0.27 to 3.19. Okay, so those are the 6 comparisons that are of interest to us. You can see that SPSS kind of overloads us with output because it does comparisons in both directions. Like, so for example, index 1 versus 2 is the same thing as index 2 versus 1. So we only need to pull out the unique comparisons from the table. Now, to conclude this, what we would do is we would look for the situations where we rejected. Okay, so the second comparison, we have rejection. And the 6th comparison, we have rejection. So then we can conclude the multiple comparison by saying at the 5% significance, the data provide sufficient evidence to suggest that the mean scores, that the mean test scores between methods 1 and 3 and between methods 3 and 4 are different, basically. Okay. And then that would be how we would perform a multiple comparison in SPSS. Again, if we wanted to, we could consider different sets of testing procedures. So if when we set up the comparison, we go analyze, compare means, one-way ANOVA, post hoc, we can choose LSD instead of Bonferroni. We can choose Tukey instead of Bonferroni. We can choose a combination of them. And then we can compare the results across the combinations to see where the agreement is. Or we can just select one, like I did in this example, and just state the results based off of that approach. In lecture, we used the Bonferroni approach, so I just chose that approach to be consistent with what was in lecture. But there's no reason why you can't consider other approaches as well. Okay, so those are the things I wanted to show you today. Does anyone have any questions about the contrast or the multiple comparisons? Okay, well, as always, if there's no questions, or if you guys have any questions at any point, please let me know via email or whatever medium suits you. As always, I'll be hanging around here until the end of the lab session. So if you have any questions about the material, or you have questions about the assignments or whatever, I'll be here to help. And otherwise, I will talk to you guys next Friday. And just as a reminder, lab assignment 2 is due on Monday. And then the next lab assignment will be posted, but that won't be due until after the reading week. All right, so if you're hanging around, I'll be here. Otherwise, have a good weekend, and I'll talk to you guys next week.